This video is sponsored by Reversible Conversions. Turn your work van into a weekend camper van in less than a minute with a reversible conversion.
This is a story about the unintended or possibly intentional consequences of a relatively simple engineering choice, and the profound implications for us all. For reasons we must assume are financially motivated, electric car manufacturers are integrating batteries into new vehicles as bespoke units that are not quickly changeable. Engineering, tooling, and testing costs all need to be repaid each time a new base chassis comes out, and resale values are impacted by expensive battery replacement costs. At some point in the future, 2 million plus batteries a year will need to be recycled with a multitude of different configurations, making this even more of a challenge and possibly dangerous. There will likely be expensive one-off shipping costs involved in battery recycling with current designs and questionable overall recycle rates. Built-in batteries take too long to charge, prices can be ambiguously high, and charger availability unpredictable. All of these things lead to range anxiety, probably the biggest barrier to buying electric. Plugging a vehicle in at home for charging rather than waiting at a garage is not always practical. Not everyone owns the property or can guarantee their overnight parking location and that it is close enough. Charging points are not cheap to install. A lot more money is going to be spent fitting these things over the coming years. The hardware is inevitably going to be imported. Imagine if all cars were powered with multiples of the same interchangeable 20-kilogram battery. With current battery cell technology, these would be able to store about 5 kilowatt-hours of energy. This would give a range of 17 miles for a Tesla-sized vehicle. Interestingly, this is about half of a typical house daily energy usage. The battery shape will facilitate auto-change capabilities. Vehicles can then be developed with a number of battery slots which don't actually need to be populated. The batteries in blue are available to fit, meaning they have been paid for but currently are not installed on the vehicle. Batteries are in essence stored for the owner by the garage network and can be fitted or removed at any location. The underground battery carousel and charging system can be installed virtually anywhere, meaning they probably will be. They are fully automated and only require manual intervention for maintenance and battery removal for recycling. When the car arrives over the battery swap station, the number and position of the batteries to be changed is communicated automatically based on the profile chosen. The driver does not need to leave the vehicle. Probably less than a minute later, the process is complete. The full batteries minus any residue energy removed is totaled up and you are charged, potentially automatically. Most people only travel a short distance each day, and they want to save money and reduce emissions when it's easy to do so. They will presumably choose to not carry around any more heavy batteries than are actually required for normal use, plus a bit of contingency. For the vast majority, that might be just 2 batteries weighing 40 kilograms. That's about 340 kilograms less than the equivalent battery-integrated car. Which is about 20% less driving energy costs through not dragging around this additional mass. Weekend excursions could have greater range. And long trips with no stopping when needed can still be accommodated. Preppers and off-road explorers could carry extra batteries on top of the full complement available in the vehicle. Range anxiety is gone for good. The same interchangeable battery could be part of an integrated home network in your luxury AI-generated future garage. Or just removed and charged in your house at night. Distributed battery storage and recharging facilities could be extremely usefully integrated into the power distribution network in such a way that energy can be borrowed back during peak requirements with little to no latency, i.e. immediately as required. This means lower peak power generation growth is required as the demand for electric vehicles increases, which is infrastructure costs that are ultimately paid for by the consumer. Recycling really does mean what it says, and dead batteries are converted back into working ones, not stripped for parts or repurposed but actually put back into the system. Only 3% of the 38 million cars and light vans on the road today are fully electric, and they make up only 15% of the 2.4 million annual sales. Looking at new vehicle registrations over time, we can see a pronounced shift from diesel to petrol in 2018 and slow rise of hybrid, and then fully electric vehicles. Looking at the most recent period post-pandemic, sales of new diesel and petrol cars and vans are decreasing slowly whilst sales of hybrid and electric are rising at a slightly faster rate. If we look at the vehicles on the road by age and fuel type, we can see why only 3% are electric. Combine this with vehicle decline curves and projected new vehicle sales based on the previous trends. It is possible to estimate the likely number of electric vehicles on the road in the future. By 2040, 5 years after the introduction of fully electric vehicles, only 45% of vehicles being driven will be fully electric, rising to 81% by 2050. Not really net zero. Given that the emissions from cars and vans makes up roughly 20% of total UK CO2 emissions, the quicker we make the switch to electric the better. Even after going mostly electric, it is worth remembering that whilst we still use fossil fuels in the energy mix, electric cars are just proxy carbon emitters. The higher the energy used, the more carbon is emitted. By empowering us to choose how much battery weight to carry, we can collectively use less energy and emit less proxy CO2. For every objective measure of comparison, covering convenience to us, cost to us and environmental impact, an interchangeable standard EV battery type is better than the integrated batteries currently being used. Let's not kid ourselves that the automotive manufacturers are our friends. The EU has recently created legislation to standardize phone charger cables. The same thing could be done for electric vehicle batteries. If new vehicles are mandated to use easily demountable standard batteries from a certain point in the future, manufacturers will design them accordingly. It is literally as simple as that. A standard battery needs to be defined so that the rest of the supply chain can with confidence start to develop the infrastructure to make, change, charge and recycle them. Standardization reduces costs because it increases volumes, which means a higher level of process automation and cheaper bought-out parts costs. Standardization opens the market to direct competition, which ensures lowest prices. The challenges are not technical, they are about political will and alignment. Internal combustion powertrains are complex machines comprising many different systems. The parts in these systems wear during use, or degrade over time, and eventually fail. The replacement parts and labor costs can be high, leading indirectly to new vehicle demand when vehicle repair becomes uneconomic. Even though there are many less failure points, the degradation of an expensive integrated battery is certain with use. This more or less guarantees older vehicle write-offs, and thus indirectly maintains ongoing new vehicle demand. Interchangeable batteries would significantly disrupt this model. People could hang on to their vehicles for longer on the basis that they still do the job they were purchased for and don't require expensive costs to keep on the road. This is a good thing for the planet and the rest of the economy, as the money saved will inevitably be either spread over other sectors or to have less personal debt burden. Not so good for the manufacturers, which could well be why batteries are currently integrated, and sadly unlikely to change anytime soon.